welcome back. We are continuing our discussion on introductory calculus, where we are looking at the definite integral. So we have examples on the board where we are told to evaluate the integral of x squared with respect to x, the limits, the lower limit 1, the upper limit 2. So these two are examples of definite integrals. They are definite integrals because the limits are given. The limits that we are talking about are these two figures. We have 1 here and 2 here. So 1 is called the lower limit and 2 is called the upper limit. Similarly here for B, -1 is called the lower limit and +2 is called the upper limit. So when an integral has the limits, it is called a definite integral. When a particular integral has no limits, it is called an indefinite integral. These ones have limits, so we are classifying them under definite integrals. So let's learn how to evaluate them. So we are saying solutions. 1a, we have the integral of x squared, values of x, 1 and 2. So we integrate the function inside the usual way we do it by the rule. So according to the rule, our function x power 2, we integrate it by adding a 1 to the power, then dividing by the new power. So we add a 1 to the power, we divide by the new power. So our current power here is 2. So we add a 1 to the power 2, we divide by the new power. So we have x power 2 plus 1, everything over the new power 2 plus 1. Not forgetting the limits of integration. Okay, so this is the integral of x power 2 with respect to x. So we proceed as follows. X power 3 over 3, the limits 2 and 1. Okay, so this is what we are getting after integrating the function x power 2. We should note that when we are evaluating definite integrals, we do not add the arbitrary constant. So that's why we have not said plus c. C is the arbitrary constant. Now, we do not add it here simply because this one is a definite integral. So when we are here, we are now supposed to substitute in the limits. So we shall say, we substitute the upper limits, we shall say 2 power 3 over 3, whatever we shall get from here, we subtract whatever we shall get after substituting the lower limit. Okay. this is how we are proceeding from here. We substitute the upper limit in there, we are getting this, and we also subtract whatever we get, we subtract whatever we are going to get after substituting the lower limit where we have x like that. So we continue 2 to the power 3 will give us 8. So we have 8 over 3 minus 1 to the power 3 is actually 1 over 3. So when we are here, since the denominator is the same, we are just going to evaluate what is numerator. So we shall just say 8 minus 1, and we shall get 7 over 3. We have done this because the denominator is the same. So when the denominator is the same, we just work with the numerator, we just subtract the numerator as we have been given. 8 minus 1 is 7. So